So glad. I mean, we haven't seen a live speaker since the beginning of the day, right? So I guess you're happy to see somebody live talking from here. And by the way, this is not my first in-person conference this year. I kicked it off at Mobile World Congress in June in Barcelona. On Thursday, there was an Analyst roundtable. I was there. So there were 21,000 people came to Barcelona for the Mobile World Congress. That was postponed from February to June. So 21,000, biggest event in the world in COVID-19 era. And but this is way down from the typical crowd at MWC, and that is 110,000 people. So, but hey, we have to deal with it. So I've seen a lot of talks actually about optical transport in wireless networks. And in fact, the previous presentation showed a bit of what I'm going to talk about. And maybe you'll have, I don't know if you attended the first presentation, well, the previous presentation, but you'll have a little bit more details about what was said previously. So I guess you're not familiar with IAB, or maybe you are, but in case you're not, it's integrated access and backhaul. So that means you have the radio access network, and typically you backhaul the traffic with something else. And those two domains are separate. We call that the transport network versus the radio access network. And it's interesting that many people actually think, from your mobile device, you go to an antenna and the stuff stays in the air. No, a mobile network cannot work without fixed transport. And as we move up, with generations and we carry more and more traffic, we need a very robust transport network. So, and the other thing is, look at that. So you think you're in a 5G world, forget about it. You think you are in a 4G world, forget about it. You're not. Technically, you are on LTE, long-term evolution, that was designed at the beginning of this century by the ITU, the International Telecommunications Union, based in Geneva, in the IMTS set of new technology for 2000, for the beginning of the century. And 4G, to reach 4G, you need features, very specific features above the LTE network. And that's what we call LTE Advanced. And that's the true 4G. And what you can see on the chart is that we are pretty much 811 LTE networks in the world. So there is no other place to go. I mean, we have upgraded all the networks, mobile networks in the world with LTE. But you can see the lag of LTE-A, LTE Advanced, the true 4G. At the same time, you see 5G moving very fast. And in fact, this 5G is not true 5G. It's fake 5G because it is anchored into LTE. So it's basically adding new radios, the so-called 5G new radio, and attach it to a 4G or LTE core. And I don't know how much experience you have with that 5G. It's very dismal at best. And case in point, Vlad, you may have seen yesterday, the founder of Light Counting, yesterday morning he had to go get a health pass in order to get in. No problem, you have your CDC card coming from the US. So in France, you're fine. But in order to get the health pass, you have to register into a system. And then they send you, the stuff by email. Well, he couldn't, it was on 3G, so he couldn't even get, the email. Can you believe that? So we're talking about 5G, we're not on 4G, and we're still dealing with 3G. I mean, this was irritating experience. And this is basically this, ladies and gentlemen, that we are talking about. So we still have a long way to go to get to 4G and get 4G right before, talking about getting 5G right. But at the same time, you have pockets of 4G networks in the world that are saturated. So you need to do something about it. And yes, you have the air interface on the radio level. You need more channels, more bandwidth. But again, if you don't have the fixed transport to backhaul your traffic, you're not going to go anywhere. So this is an illustration, a simple illustration that I am taking from AT&T. So what you see here, you have rings actually, between core and aggregation, access and aggregation. Those rings are fiber optic rings. Now, if we go toward, if we look at the access, so the typical architecture is right there, what we call DRAN, Distributed Radio Access Network. And this is, you may have heard about base station. So this is one in all, or all-in-one base station. That means you have all the processing, signal processing unit, what we call the baseband unit, that is with the radio unit at a site. And this is the most common mobile network. It's everywhere, except in Korea, Japan, China. We see more and more of, we see more and more. We see more and more that kind of architecture moving toward the West. But they have deployed what we call centralized radio access architecture, which is just right there. So basically, you take the BBU and you separate the BBU from the radio unit. And by doing this, you can actually connect many radio units to just one BBU. So you save space and you save money. It's actually a lot of money saving, but you need good fiber transport. And that means you are creating a new link, basically, between the radio unit and the baseband unit, BBU. And this is what we call the front haul. Then from the BBU to the aggregation network, in fact, to the access ring, you need a link, and this is the backhaul. But even in this access ring, this is also called the backhaul. So this is what we are talking about. And so we're also talking about more and more disaggregation. In fact, this is, the beginning of disaggregation, of moving parts, separating parts in the base station. But with 5G, we are going further in disaggregating the radio access network. Now, fiber. I said, since the beginning of my presentation, if you don't have a good transport network, your experience with this is going to be miserable. And what you see here is that fiber is growing, but there is still a lot of microwave. So the microwave is using very specific spectrum, particularly in the millimeter wave range. So it's basically separate. As I said at the beginning, you separate your radio access network that we are all using with our mobile devices from the transport network. But most of the transport network so far has been on wireless. And I don't know if you knew that. And this is microwave. The rest is fading, because at the beginning of this century, with GSM, we were using copper lines all the way to ATM at the very beginning of this century. And then, 3G came, that couldn't make it. In fact, 3G was a big failure. Who, is using 3G? Well, us coming from the US and roaming here, and in this area, back on 3G. So, but that's the way it is. So now, looking at the increase in capacity needed to transport a huge chunk of traffic generated by LTE Advanced, that means true 4G, and then the 5G that is coming, which is still, as I said at the beginning, anchored into the 4G network, you still need to keep up as opposed to catch up with that demand. So there is a promising new technique called integrated access and backhaul, where you want to use the same spectrum and potentially the same frequency to actually do both, send and receive the signal from your device to the baseband, well, to the radio unit, and also use, that radio unit to communicate with other radio units or other, termination units to backhaul the traffic. Now, before moving into, the more details about IAB, I also said at the beginning of the presentation and showing on the AT&T slide how you disaggregate a base station moving BBU from RU. This is showing how to actually rip the BBU apart. And I also mentioned in the previous presentation, the gentleman had, showed how to use, new optical technology to connect CUs and DUs. So here you are, ladies and gentlemen. So the RU, you can touch it. That's where you have all the antennas, right? So, an antenna, you're not going to put antenna on software. No, it's still hardware. But there is a lot of improvement in antennas with, you may have heard of multiple input, multiple output. So cramming a bunch of very small antenna arrays into a radio to basically increase the capacity. So you may have, this is what we call MIMO. So this is the radio, but what's interesting about the radio, you have the physical layer because the radio is physical. But the idea was to split actually that physical layer between a low physical layer where you have the stuff that can, still stay on hardware, and then move the high physical layer into the distributed unit, DU. So you have all the protocols, and at 3GPP, in the standard bodies, they actually looked at every single protocol stack and how to separate. So basically, it's kind of a Lego model where you can pick and choose the architecture you want. But in the end, the most, so far in the 5G commercial networks we see in the world, it's the option 7.2, and you see the split option 7, just before the RU, and then the split between the CU and the DU. So what I'm talking about here is that the CU, the connection between the CU and the DU is creating a need for a new transport link that is called the mid-haul. At the bottom, you can actually see the pioneer, Korean Telecom, KT. So if you remember the Winter Olympics in Pyeongchang, they actually tested that option 7.2 in order to test, measure and figure out whether or not it was a good idea to use that configuration or architecture for the commercial deployment that came in 2019. And you can see actually that they made a little tweak. They found that CPRI couldn't make it. CPRI was not providing enough capacity to get the stuff that was hitting the radio unit. So they moved to an Ethernet link, as you can see at the bottom, which is the commercial 5G deployment of Korea Telecom. But they put Ethernet as well between the DU and the CU. But another thing that is very important to know about those 5G networks is that you have few cases like KT, or in Japan, they are moving into that direction as well. But the other 5G networks, and you saw at the very beginning that we are at 176 5G networks in the world today. Again, not real 5G, because still anchored into the 4G network. But anyway, DU and CU are together So, you think about it, wow, that's great, that's fantastic, brilliant, your honor. But today, we're still back at the beginning, at my slide of the beginning of what I showed with the AT&T network, because the DU and the CU are together. And why? Well, because there are no use cases. Well, there are no use cases. There is, you heard about all the fancy use cases we're talking about with 5G, right? Yeah, great. Who is paying for that, right? Low latency stuff, very low latency. So if you need very low latency, then you need to have, the DU somewhere close to the RU. You can attach actually several RUs to the DU and then leave the central unit somewhere else. But where are the use cases? So we see actually some interesting use cases under the bucket of Industry 4.0. So I don't know if you heard about this. In the Industry 4.0 domain, the World Economic Forum and McKinsey, the consulting company, they are tracking, they have created a new category, the Lighthouse Network of Industry 4.0 factories in the world, trying to count the number of factories that are using wireless for automation, putting robots, connecting the robots together so that the robots communicate and you remove as much human interaction as possible. And we already have some of these few factories using that kind of separation. In fact, you have the Nokia factory in Oulu, where they manufacture all the base stations. So I visited it when we could travel in November 2019. So, and it was very interesting to see all the robots and see, the design of the applied design of this architecture. But Ericsson actually launched its factory in Louisville, Texas, last year in May 2020, right, in the middle of the pandemic, to manufacture the base stations that they ship to Verizon and AT&T. But there are many other factories, and in fact, at this point, most of the factories like this are in China. So I don't think that is a big surprise for anyone here, right? Good example of the most advanced network in the world. So this is, the best illustration of what I showed in the previous slide. And I don't know how much you have heard about Rakuten Mobile, but this is the, the highest profile in the world in the mobile industry because they are shaking the mobile industry. This is the fourth mobile players introduced in Japan in 2019 under the Abe-san prime ministership, who wanted to do like in France, when we saw the introduction of free. Lots of common features. Xavier Niel is a billionaire. Mirikitani-san is also a billionaire in Japan, so he has billions of yen, Japanese yen, billions of dollars, euros, and say, hey, look, I got the license, now let's play. So he hired, the brightest minds in the world to actually be brave and pioneer this architecture, this revolutionary architecture. So what you see, you have millimeter wave, so you have, the 28 gigahertz spectrum. So you have a 5G new radio, and then you have actually 4G and 5G sub 6 gigahertz. You have to basically connect the radios to what they call a site terminal unit, and then use WDM to go to the DU. So this is a very sophisticated DU because, as a matter of fact, it's not the DU alone. As you can see, the RCP is their own Rakuten communication platform that includes some core functions, mobile core functions. Then it requires an operation system and optical switching. So this is, what they call the edge infrastructure that includes the distributed unit with other functions, network functions, and this is basically to increase the efficiencies and to be prepared for the future when the use cases are coming. Because today it's just basic, service of offering mobile broadband, for us, for humans. But they are, they have already thought about the next phase of use cases. So this is, and then you have, in the core network, that's where you have the central unit. But again, it's interesting to see that you have the same configuration that, at the DU level, but they have already brought a lot of intelligence at the edge of the network. So this is the Rakuten example, and again, this is the best example we have in the world when we talk about this revolutionary architecture. The next to come is Dish Network in the United States of America, and in Europe, you'll have Dish in Germany that actually has selected Rakuten to build a network, to build their network in Germany. So you'll see, some interesting shakeout in Germany to come. So now, what is integrated access and backhaul doing in there? Well, as I said, and you can see, on the picture, the idea is to share actually some of the radio spectrum to backhaul the traffic and to put that traffic, into one place instead of using microwave, which is a separate entity, instead of using fiber, again, another separate entity. Let's think about, using the same radio. So this is not a new concept per se, because it was already introduced back at, in 2010, when we were starting to review how we could build 5G. But at that time, 2010 was the beginning of the construction of long-term evolution network on the path to 4G. But, there was no commercial interest. And by the way, this was really pushed by Ericsson. So why there was no commercial interest? Because, well, we were at the beginning and we didn't know how, things would work in those LTE networks. And we were so comfortable with the microwave technology that, we were like, why changing the game? Let's keep the bandwidth, the LTE bandwidth, for mobile communications, and let's not use a piece of it to backhaul, since we have, those microwave links. And Ericsson, of course, is a leader in the microwave business, as it is a leader in the radio unit business and baseband unit business. So, and we'll see actually on the other slide. Another thing I'd like to mention is, so why now? So I said with LTE, let's not use, the entire bandwidth. Let's use the entire bandwidth for mobile communications only, because we don't have that much bandwidth at the end of the day, and we are riding Shannon's limit. So yeah, in 2011, we are already riding Shannon's limit in LTE networks. So it was not, the right moment to mess up with that spectrum. Now we have huge chunk of spectrum that is being made available to us. That is millimeter wave. In the millimeter wave domain, you can have swath of 100 megahertz spectrum. And in fact, yesterday I talked to someone who was doing some interesting research in China, and was actually using a channel of 1,000 megahertz. So we are very far away from that. But if we can get 100 megahertz straight, already it's fantastic. But I'm seeing places in the world where they get 400 megahertz straight of spectrum. So then, even at 100 megahertz, you're like, whoa, I have a big channel. So in that channel, I can get a little piece of it and transport my traffic, instead of deploying more microwave and more fiber, particularly in the case of network densification, where you are adding base stations to keep up with the traffic. So this is basically what I'm talking about, and if you want to have more information, I invite you to go get the Ericsson technical review. So in section A at the top of the slide, this is what we have today. So you have one frequency, F2, is being used for this, and on the mast you have a receiver, the FWT, the fixed wireless terminal, that is basically getting the signal from F2 and using another frequency and sending the signal to the backhaul core instance, and this is where you basically have to aggregate the backhaul traffic, and so this is separate from the core, the mobile core network. So sometimes it's at the same place, and this is the top line. But in many instances, actually, those two domains are separate. So now think about the cost of the installation, right? So now you move to the bottom. Then you can actually still use two frequencies, but in the same chunk of spectrum, or you can use the same frequency. But what you have now is the same principle. You need to terminate the traffic and send the traffic to another antenna, and you can actually, from that antenna, you can resend that traffic to another antenna, and finally, to the core. So, and that's the case. You are using two frequencies, but if you use the same frequency, then it's called virtual IAB. So now, why are we thinking about this? So I said, now we have big swath of bandwidth. That's going to help the process of bringing more capacity to mobile network. Saying big mobile capacity in the radio access network means big transport network. And we have to look at, network densification, adding more base stations everywhere. And that's why this is very costly, particularly in millimeter wave where they don't go that far. And that's why IAB now is gaining traction, because that's going to relieve, a lot of cost issues. This is, to give you an idea of what we are talking about. And, I talked about it in 2G, 3G, 4G, sub 6 gigahertz, we don't have that big chunk of bandwidth. You can see, 5 megahertz, 10, 20, 40. So you're not going to do IAB with that, and that's what I said. So now you have to go look at the millimeter wave spectrum, more than 100 megahertz. But you also have to think about the overlap, because most microwave links are actually being used for other things. You have, backhaul, Wi-Fi, but it's also overlapping with millimeter wave. So, in the end, IAB will be complementary. We need more fiber. Fiber is not going away, as we saw since the beginning of ECOC. I've seen many presentations where they talk about optical transport for wireless networks. At the same time, microwave is not going away either. But IAB is coming to the toolbox to help put more base stations, particularly millimeter wave. Think about, a microwave with that kind of light. Millimeter wave is just, that focused light from the projector. So you're not going to go far. The area is very small, but we need these hotspots in urban area to pump up the bandwidth. And we need to backhaul that traffic, and that's why IAB is going to be fantastic. So with that, I'm done. So thank you very much for your attention, and if you have any question, I'm right there.
Thank you very much, Stéphane. Oh, it's great to see a live talk. Is there any questions for Stéphane? So, if there's no questions, I'll ask a couple of questions myself. So, As you indicated at the start of the talk, I mean, there's a lot of talk about 5G, but in the practical sense, I mean, I suffered the same problems yesterday morning too with just 3G. When do you think we will see 5G more sort of ubiquitous in the networks, both in Europe and as well as in the United States?
It's going to take some. I mean, even though everything is moving fast, it's going to take some time because of the cost. So at least in the US, COVID-19 has not affected anyone. There is a strong push. We see Verizon deploying millimeter waves like crazy. So that is really helping. But you talk, I mean, helping in urban areas and to some extent suburban. But you'd say, a very important word, ubiquitous. So, and this is related to something Dr. Gladish showed yesterday from Deutsche Telekom about the long tail, basically where the traffic is. So the traffic, most of the traffic is in urban areas. That's where all the people are. And then, you go that way in rural area. And in rural area, it's terrible because, the business case is miserable. So, and that's why, how far can you push? So the best way to push that far is using very low spectrum, 700 megahertz. So this is what AT&T and Verizon and T-Mobile did in the US. So, but it took a while. Look, if we look at this, they started in 2010. We are in 2021. It took pretty much 8 to 10 years to get an LTE signal, right? So now T-Mobile pushed 5G, but listen to this, ladies and gentlemen, 5G at 600 megahertz. Come on. So you have ubiquity, but what do you do with at 600 megahertz? Not that much. You're not going to download, a big file. No, that's not where the capacity is. But, and that's the problem. So if you need connectivity, you'll have connectivity, and this, it's part of the 5G playbook. But you're not going to be able to upload, a picture on LinkedIn, Facebook, or whatever. So it's going to take a long time.
Yeah, I agree. I mean, I think over the next 5 to 10 years, it's going to take a long time for 5G to be everywhere. And by that time, as you said on your slide, people will start thinking about 6G, whatever that means. And the next
in fact, the 6G discussion has already started.
Yeah.
But, I can tell you, prediction will call 6G all the stuff we failed to deliver with 5G. That's the way I look at it. But you already have big 6G programs, actually, China, Japan, Korea, Europe, US. It's unbelievable, but that's nice because it takes typically 10 years from the thinking to commercialization. So, we are just on time, but let's get 5G right.
Oh, absolutely agree. Is there any more questions? All right, well, let's thank Stéphane again.
Thank
Great
you.
Talk.